In this video, we're going to talk about safety switches on gas furnaces and refrigeration bearing units. Some examples of safety switches on a gas furnace is like this flame rollout switch, which is usually located near the burners on a gas furnace. If the heat exchanger becomes plugged or the gas pressure gets too low or combustion air is inadequate and the flame rolls out of the burner, this switch is a safety to shut the furnace down and prevent a fire. It is a manual reset switch that requires someone to physically reset the switch before the furnace will resume operation. Sometimes the flame rollout protection is provided by a fuse like this that has to be replaced once the flame has tripped the fuse. Some more examples of safety switches are furnace high limit switches that are designed to protect the heat exchanger from overheating. These switches are automatic reset. On the refrigeration side, safety switches are like these pressure switches used on refrigeration systems to protect the system from low or high refrigerant pressures. Another type of safety switch are these pressure switches that are used on gas furnaces to protect the furnace from either a blocked vent or a blocked condensate drain. So one of the common calls that we get in tech support regarding safety switches is that the technician has checked the continuity of the switch, and if the switch is supposed to be closed, they confirm with a voltmeter that the switch is closed, but the furnace is still flashing a code that shows that the flame rollout or the limit switch or a pressure switch is still open, and they question what is going on. Well, what you have to understand is that even though the switch may show that it's closed, the board may not be seeing that it's closed because of some problem in the wiring where it goes back to the board. So what you need to do in a case like that is, instead of checking the continuity of the switch, you need to go back to the place where the safety circuit enters the board and check and see if the circuit is closed at that point. And also with the pressure switches where they go into, in this case, plug PL15, you need to check and see if the board or the plug is showing that that switch is closed. This is often overlooked by technicians who think the switch is closed by their continuity check, but they don't consider there could be a break in the wire or there could be a loose connection between the switch and the board. The same is true of a refrigeration circuit. Here we have a low pressure switch, a discharge temperature switch, and a high pressure switch in the series safety circuit. These switches may show that they are closed, but again, you have to trace the circuit back to the board to make sure that the circuit is closed where it enters Y and T1 at the control board. This is a diagram of one of our inverter-driven product. You have your VFD and your control board, and on the VFD you have a high pressure switch that is monitoring the pressure of the refrigerant in the system. Again, the high pressure switch may show that it's closed, but you need to check the wiring back to the plug where it plugs into the VFD and make sure that you have a closed circuit there. This diagram is of a larger system that has two compressor circuits. And again, you have your low and high pressure switches on both circuits. And again, you have your wiring going back to the control board. So even though the switch may show that it's closed, it may not show it closed back to the board through the wiring and the plugs. So on every system, you need to double check the wiring to make sure that the closed switch is communicating back to the board that it is definitely closed. I always emphasize this in my videos, that if you're making tests on plugs on any system, you must have the skinny probes to get into these plugs. The fat probes will definitely disturb and destroy plugs and the connections. So you may make the problem even worse than it is by sticking your fat probe in the backs of these plugs. So if you're going to be making these kind of tests that we've talked about in this video, please get these skinny probes. It'll make it a lot easier for you to test, and you will also protect the plugs on all the equipment so they will not be damaged.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.